statistics hypothesis testing question that was left in the discussion forum. So specifically, we're told a manufacturer has a machine that produces lollipop sticks. The length of a lollipop stick produced is normally distributed with an unknown mean mu and a standard deviation 0.2. And this person believes that the machine is not working properly and that the mean length of the lollipop sticks has decreased. He takes a random sample of size into test at the 1% level of significance. The hypothesis H0 is that mu is equal to 15 and H1 is that mu is less than 15. And then we've got 3 questions of that to answer. So before we go through the question, we'll just go through a little bit of stuff to do with normal distributions and hypothesis testing. So in general, the whole point of a hypothesis test is that we posit some fact about, we have some facts about a population, and then we test that by taking a sample of the population and running the data through that, and then we set up a hypothesis, which is that the original fact about the population is true. That's your null hypothesis H0, and then your alternative hypothesis H1, which is that the original fact about the population is false, and then we perform a test at a certain level of significance, and depending on that, we can either reject or accept the null hypothesis. Within that structure, there are clearly 2 types of errors. We can reject the null hypothesis when the null hypothesis is true. So that's what we'd call a type 1 error. And we can, or alternatively, we can accept the null hypothesis when it's actually false. So this is a type 2 error. So hopefully you've seen this in class before, but it's important to remember, especially for the context of these questions. Okay, the significance level is defined to be the probability of a type 1 error. That's by definition what the thing is. So in this specific question, a 1% level of significance is that we want there to be a 1% probability of a type 1 error, being that we reject H0 when H0 is true. So there'd be a 0.1% chance that H0 is true, right? Significant, yeah, and then the critical value is scaled along the axis. What specific value of the population that the data can take is reflected by the significance level. We're dealing with normal distributions, Gaussian distributions, which have this shape. Specifically, this question is referring to a one-tailed test because we just have mu is less than 15. We could have situations where we have mu is just not equal to 15, in which case it would be two-tailed, and we'd have to split the significance level in half and consider 0.05 at this end and 0.05 at this end. Okay, and then some other stuff which we'll go through as we go through the question. But part A is write down the size of the test. Now, this is one that's worth checking with your teachers, and it depends what your exam board you're doing. But generally, when I've met this term before, size is just, and what I've written down here, the probability of a type 1 error, which is exactly the same as what the significance level is. So I'm not 100% confident on this answer, and I don't have a mark scheme for this question. But size should just have a clear definition in whatever exam board this question is from. Read the, I think it's Edexcel, but it's pretty much always the same thing. So size is equal to 0.01 because it's just the probability of a type 1 error, which is the significance level. Okay, B is a little bit more complicated though. So given that the actual value of mu is 14.9, calculate the minimum value of n such that the probability of a type 2 error is less than 0.5. And this is a 6-mark question, so clearly there's a lot to do. I think it's easier to just jump into this one and then justify it as we go along. So first of all, what we want to do is